In today's lecture, we are going to begin with the chapter Matter in Our Surroundings. So first let's begin by defining what matter is. Matter. So we define matter as any substance and that has mass and occupies space. So matter is any substance that has mass and occupies space. So just like any solid that we see, the notebook, the desk, then you consider table, you consider the wardrobe, anything that you consider a solid, that is matter because it has mass and it also occupies space. And if you consider any liquid also has mass and they also occupy space. So solids and liquids both come under matter. And any gas, consider air also has mass and occupies space. We know that air occupies space. The empty portion that is present inside our home is completely filled with air. Now how to see that air has mass? Let's perform an experiment to understand that air has mass. So let's say we take a balance, connect it to a fixed part, and to the two ends we have two balloons that has been inflated and hanged to this one. So as the balloon, both of them has equal mass, what happens is they show this scale that is there that measures the weight. They are horizontal. But say what is happening is I am taking out air from this one. So what happens is we see that as the air is removed from one of the balloon, what happens is the one which has air inside it, as it is heavier, it comes down. So this shows that air has mass because an inflated balloon is heavier as compared to a deflated balloon. This shows that air also has mass. So now we know that air has mass and air also occupies space, therefore air is also matter. So any gas that we consider is also a matter. Okay. So matter is the form of 5 basic elements we call this basic elements as the Panch Tattva. Panch meaning 5 and Tattva meaning elements. So the 5 elements are air, earth, fire, sky and water. first point or the first statement that we are going to understand is that matter is made up of particles. For a long time, two schools of thought prevailed regarding the nature of matter. One school believed that matter to be continuous like a block of wood, whereas the other thought the matter was made up of particles like sand. So we know that matter is made up of tiny particles, and those smallest particle in a matter is called as atom. Now let's see how these atoms are there and how they are placed in different matters. Say we take a beaker and we have water inside this. Okay, here we have water. In this, what we are doing is we are taking a spoon of salt and we are adding it over here. So we have some salt over here. This is water. This is salt. So after stirring this, what we see, after stirring this with the help of a spoon or a rod, small substance like this, what we see is after stirring is that this water and salt they mix with each other. So we have salt particles all over water. We cannot see these salt particles with our naked eyes, but the salt particles are present all throughout the water. So this happens because the particles of water was very small, and in liquids there is spaces between the particles, and since there were spaces between the particles, that is why particles of salt were able to go in between the spaces that was present in between the liquids. So liquid has spaces between them, and the salt, when we mix them, what happens is the salt is made up of very small particles. Since it is made up of very small particles, those particles cover this interparticular spaces that is there between the water molecules. So these salt particles, as they are very small, they take place in between the particles, that spaces that are present, and we see that the volume of water that was initially taken, even though we add salt to the water, the volume of water does not rise. It remains as it is. So with this we conclude that the particles that matter is made up of is very small. Okay. So what do we consider, what we get over here is that, so when we dissolve salt in water, the particles of salt get into the spaces between particles of water. Okay, so matter is made up of very small particles and we call them as atoms or molecules. Okay, next point is that how small are these particles of matter? So for this we'll again consider an experiment. So what we are doing is we are again taking a beaker, say we have water in the first beaker and we add, say this is a small piece of potassium permanganate. Potassium permanganate, what it does is that it dissolves in water and gives color to water. This, as we put it inside water, what happens is water, it becomes colored. So the water becomes color. Now what we are doing in the next step is we are taking from here a test tube filled with this water solution and put it inside the next solution. So this was our water initially. Now as we put one test tube of this one, what happens is this again gets colored. So what a difference is that first when we put this, what happens is it produced a very dark colored solution, and if we take one test tube full of this liquid and we put this over here, now this solution also converts a little colored but not as colored as the first one. And say if we take again a test tube from here of this one and we put it to the next one, then what happens is the water over here again gets colored. And this is more lighter as compared to the previous case. So the number of times we keep on putting from one to the other and from the other to the next one, what happens is the intensity of this colors keeps on decreasing. So this experiment shows that a few crystals of potassium permanganate can color a large volume of water. If we take little volume, then it creates a very dark color. And if we pass it on, keep on passing it on, it's still coloring the water, but the color becomes faint. So even one small crystal, some small crystals can color a large amount of water. So if we keep on continuing this process, then also it will keep on coloring the liquid, but the intensity of color will keep on decreasing. So from here we conclude that the particles of matter are very small and they are small beyond our imagination. So each particle is so small that we cannot even see one particle, that atom, with our naked eyes. So this experiment shows that just a few crystals of potassium permanganate is able to color a large volume of water. So we conclude that there must be millions of tiny particles in just one crystal of potassium permanganate, which keeps on dividing themselves into themselves into smaller and smaller particles on repeated dilution. Dilution basically means what we are doing is we are diluting it. The amount of solute that is present in the solution we are decreasing, so we are creating a dilute solution. So on repeated dilution. Okay. So from this what we conclude is that the particles of matter are very small beyond our imagination. Okay. Now we come to characteristics of particles of matter. So the first characteristics is that particles of matter have space between them. The reason why we added salt and the volume of this liquid did not increase is because as we add salt to this, what happens is this salt covers the interparticle space that was present between the water. That is why the volume of water did not increase, because it covers the intermolecular spaces between the water. So that is why we conclude that with the help of this experiment we can conclude that particles of matter have spaces between them. And also to remember over here that when we consider a solid, so a solid has a densely packed molecules just like this one. They have a very less intermolecular spaces between the particles. This is what a solid looks like on high magnification. A liquid, whereas, is relatively much free. They can move from one position to the other. So this is what liquid looks like on high magnification. The particles of liquid look like. And gases, they are so much dispersed, they have the highest intermolecular spaces between the particles. So this is what gases look like on high magnification. Okay. Second point, particles of matter are continuously moving. Okay. Now understand this clearly that solid, they are very densely packed and they cannot move from one place to another. That is why what happens is for a solid particle, they vibrate about their own position because they cannot move from one point to another. They are very densely packed. Liquid, whenever we take a liquid in a container, so this liquid that is present over here can move about inside the volume of the liquid, whatever it is. So in the liquid itself, it can move in any direction, anywhere, because the liquid particles are relatively free to move. They have spaces between them and they can travel inside the liquid. But gases, when we consider, they have large intermolecular spaces between them and it takes the shape of the whole container. It is free to move inside the whole container wherever it wants to. So particles of matter in case of gases have a greater degree of freedom. They can move in any direction, anywhere. It covers the whole container in whichever we keep it. Okay. So particles of matter are continuously moving and hence possesses kinetic energy. Kinetic energy is the energy possessed by a body whenever it is in motion. Since now these particles are in motion, so what happens is they have large kinetic energy. Now if you heat these particles, what happens is heat is basically a form of energy. On heating, they gain energy and their kinetic energy increases. So they start moving with more random motion. So whenever we heat the particles, so increase in temperature, the kinetic energy also increases. So as the temperature rises, this is an important point, as the temperature rises, particles move faster So this results in increase in kinetic energy. So with increase in temperature, the kinetic energy also increases. Okay. And the third characteristic is that particles of matter attract each other. Okay, so the strength of intermolecular spaces of attraction is inversely proportional to the intermolecular spaces between the particles. So we know now that the solids have the least intermolecular spaces. So as this has the least intermolecular spaces, this will have the maximum intermolecular force of attraction. The force of attraction is inversely proportional to the intermolecular spaces between the particles. The liquid will have a moderate force of attraction and the gases will have the least, because it has the maximum intermolecular spaces between the particles. So they will have the least intermolecular force of attraction. So with this, we differentiate between different states of matter: solid, liquid, and gases. So solids are rigid, liquids are not rigid, that is, they can flow and are called fluids. Gases are not rigid, they can also flow and are also called as fluid. Second point, solids have definite shape and volume. Liquids have definite volume but no definite shape, and gases have neither definite shape nor definite volume. It takes the shape of the container and occupies the whole space of whatever container we keep it in. And liquid takes the shape of the container but its volume remains constant. The volume of a liquid, it does not change. Third point, solids cannot flow. Liquids can flow from a higher to a lower level. Gases can flow in all directions. Fourth point, the solids cannot be compressed. Liquids can be compressed to some extent. Why they cannot be compressed is because they already have very less intermolecular spaces. So we cannot compress them. But liquids, as they have certain intermolecular spaces, will be able to compress them to a certain extent, and gases will be able to compress them highly. So liquids can be compressed to a certain extent, gases can be easily compressed. Fifth point, intermolecular attraction. So the intermolecular forces in case of solids is maximum. Intermolecular attraction is maximum. Intermolecular attraction is less than that of solids, and in case of gases, intermolecular attraction is least. Point number 6 and the last point. So solids can be stored without a vessel because they have a fixed shape and a fixed volume. So they can be stored without a vessel. Liquids, they do not have a definite volume, so we need a vessel. So this cannot be stored without a vessel. And gases also can be stored since gases flow in all directions, so they can be stored only in closed vessels. If the vessel is open, then the gas will escape. So gases can be stored only in closed vessels. So with this, we come to end of today's lecture. Thank you.